I'm Anil Kumar. Welcome to my series on trigonometry. Here we have a very interesting question, and the result of this question will be applied in many places to solve some complicated questions. We need to write an equivalent expression for cos A times cos 2A times cos 4A till cos to the power of 2 n minus 1A. One of these is the right choice. So you can always pause the video, answer the question, and then look into my suggestions. So let's try to work on this. So we have cos A times cos 2A times cos 4A and so on. Now the results clearly indicate that we have a sin A in the denominator. So let's do one thing. We can multiply and divide by sin A. Now sin A cos A, does that remind you of something? Well, we know that sin 2A is equal to 2 times sin A cos A. Right. So what we can do now is we can make it 2 times, and so we'll multiply and divide by 2 also. As soon as we do this, we notice that these terms can now be written as what? Well, the numerator here is 2 sin A cos A. So 2 sin A cos A is sin 2A, so I could write numerator as sin 2A. And in the denominator, I get 1 2 and sin A. And then I have my series, which is cos 2A times cos 4A till 2 to the power of n minus 1A. So we got 1 2 and we got sin A in the denominator. Now what we can do? Well, we have sin 2A and cos 2A. We only need a 2 in the numerator. So we can again multiply and divide by 2, right? So let's now divide and multiply by 2. Since we already have one sin 2A, right? So as you can see, this process can be repeated, right? And 2 times sin 2A cos 2A, well, this time gives you sin 4A. But in the denominator, we have 2 square and the term sin A. So the denominator sin A remains, and we have consumed up to cos 2A, right? And what we are left with is cos of 4A, right? And so on, correct? Again, we can actually multiply and divide by 2, and we'll get our result. So what will it be? And then we have to see what really happens if we go up to 2 to the power of n minus 1, right? So we'll generalize it now. So we have these three combined together. We get sin of 8a. 4 times 2, 8a, and the denominator is 2 to the power of 3, which is also 8, right? Sin a, and now we'll multiply by cos of 2 times 4, which will be 8a, right? It will go up to cos of 2 to the power of n minus 1a. So what you notice here is the term 8 is same as the term 8 for the next term. So at the end, we should end up with what? Right? We should end up with 2 to the power of 3 is here, right? So what we have done here is that we have used 4 to get 8. Do you see that? So this number 4 gave us 8. So if we use this term, then we will get what? 1 extra power, right? So we get sine of 2 to the power of na, and here it is the same thing. 2 to the power of 3 and 8 is same. So we get 2 to the power of n, and then we have a sine A term. Does it make sense to you? Correct? So we get A as the right option. Perfect. So that is how we can look into this particular series. So I hope it makes sense. I'd like you to closely look at it, then I'll give you a question which is very similar to this. So I hope you have understood the process. Now, here is a question for you. It is almost the same question, written in a different way. Simplify the expression in terms of sign ratio. Cos of x by 2 times cos of x by 2 square times cos of x by 2 cube, and so on till cos of x over 2 to the power of n. So you can now pause the video, answer the question, and then look into my suggestions. Okay, now this time what we are going to do is we'll reverse the order, because what we learned was that if I have cos of A times cos of 2A till cos of 2 to the power of n minus 1a, then this was equal to sine 2 to the power of na over 2 to the power of n times sine a. Correct? This is what we learned. So there we were actually multiplying by 2. Here we are dividing by 2. So I'll do a simple change. I'll kind of flip the order. So I could rewrite this as cos of x over 2 to the power of n times cos of, I could write this as 2 times x over 2 to the power of n, right? So that becomes a term before this. And I could continue this series till the end of it, which is cos of, so what am I doing here is, when I flip this to get to the next term, I multiplied by 2, right? So when I get to the term here, I have to multiply by what? We have x to the power of divided by 2 to the power of n. Now, to get 2 here, that means n plus what, right? So I'll say 2 to the power of n minus 2. Do you see that? So if I do n minus 2, in that case, when I take away n from it, I get 2 to the power of minus 2, which will give me second last term, right? So the last term will be cos of 2 times n minus 1, correct? X over 2 to the power of n. Do you see that part? Correct? So if you follow the same strategy, substituting that a for you is equal to x over 2 to the power of n, then you could actually write the series in the same fashion, which is cos of a times cos of 2a and so on till cos of 2 to the power of n minus 1a. Correct? So therefore, this could be written as sine 2 to the power of n over a divided by 2 to the power of n times sine a. A for us is x over 2 to the power of n. So I could now write this as sine 2 to the power of n times x over 2 to the power of n divided by 2 to the power of n times sine x over 2 to the power of n. Does it make sense to you? So that is how we could rewrite this whole series, and that's our result. So I hope that helps, right? So this result is kind of very important, since it could be sometimes combined with other questions. So I hope you understood the derivation of this result. Now look here, we have a question for you which is based on limits. So you saw the title, Calculus Limits Trigonometric Functions. So now the question for you is to evaluate the limit when n approaches infinity for the series which you just worked on. Perfect. So I'd like you to pause the video now and answer this question. Does it make sense to you? Now let's try to evaluate the limit when n approaches infinity for cos of x by 2, this is cos of x by 2 square times cos of x by 2 cube, so on, till cos of x by 2 to the power of n. So what we just learned is that I could rewrite this as limit n approaches infinity, and all these terms can be written in terms of sine, right? So we could write this as sine of 2 to the power of n and x over 2 to the power of n, right? Everything divided by 2 to the power of n times sine of x over 2 to the power of n. Is that clear? Perfect. So that is how we can actually write this series. And now, n approaching infinity, we can actually easily find this limit. But the critical part was to get to this expression from the original condition given to us, right? So we could write this as limit n approaches infinity. Simplify this, we get sine of x in the numerator. The denominator is 2 to the power of n times sine of x over 2 to the power of n. Now we could write this as limit n approaches infinity. We have sine x in the numerator over. Now this expression, we have 2 to the power of n and sine of x over 2 to the power of n. So to find this limit, what we can do is we can multiply and divide this expression by x over 2 to the power of n divided by x over 2 to the power of n. Correct? So if we do that, in that case, what happens? Well, sine x is independent of n, so that's fine. So that is sine x over. Now, this portion, 2 to the power of n, gets cancelled with this 2 to the power of n, right? And what we have here, let me use different thing with this combination, which is sine of x over 2 to the power of n divided by x over 2 to the power of n, right? And we are working with the limit n approaches infinity. And all this is being multiplied by x. So I can rearrange this and we can get sine x over x. This is independent of n, and we get limit when n approaches infinity for what? For sine of x over 2 to the power of n over x over 2 to the power of n, right? And the numerator, we have 1. Let me write this over this, right? So slash, that is in the denominator. Does make sense to you, right? So now we know this limit is 1, right? Sine theta over theta. 1 over theta, I should say, and n approaching infinity. So the result here is sine x over x. So that becomes the answer for the given question. Does make sense to you? So that's an excellent question, and I hope it helps you to understand the whole concept. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.